Hello MYP3, we are going to look at drawing the line of best fit on the scatter diagram. So in the previous class you looked at how to draw the scatter diagram. Now we are going to draw the line of best fit. So basically these are our scatter diagrams. So we are going to draw the line of best fit. The rule for drawing the line of best fit is we will find the mean of the two variables. So the variables from your list of from your tables, all the x values and all the y values, you'll find the mean, which is the average of the values of the first column. Then you'll find the average of the values of the second column, and then plot it on the diagram with a different color so that it stands out, and then draw the line of best fit. Line of best fit is just like a straight line drawn right in between all the dots, right? Okay, this is not a linear relationship. That's why we will not draw the line of best fit for this. This is not linear. It doesn't fall on a straight line. Linear are the ones which fall on a straight line. So this one is linear, you can see. And I can draw the line of best fit by drawing a straight line right in the middle of all the dots. And if I have to describe, you can always tell me whether it's strong or moderate, positive or negative. Yeah, so it has a negative, I would say, strong correlation because the dots are very close to each other. Okay, now let's look at this situation. Okay, that's a strong correlation. The dots are very close to each other, and we have drawn the line of best fit. Line of best fit is a straight line that's drawn closely to it. Okay, what about part B? I think this cannot be the line of best fit, because can you see the straight line is not in between the dots. In here they are trying to just draw the straight line roughly by in between the dots. This is like on one side of it, so it is not a it's not a good line of best fit. If you look at part C, this one too, it cannot be a good example of a line of best fit, because the lines are not going the line is not going in between the dots. For part D, you will see the line of best fit is going right in between the dots. So this is a good example of a line of best fit. This is not a good example. This is not a good example. This is a good example of a line of best fit, right? For E and F, no, because the line of best fit we want to be drawing in between the line here, right? So that's not a good example. For part F, this is still wrong. This is also wrong. So line of best fit should have been drawn something like that, right? Okay, in number 2, if we had to draw the line of best fit, where would you be drawing? You would be drawing it somewhere right in the middle of all the dots here, and we would say that it has a positive gradient, right? For this one, the line of best fit would be drawn something like this. We would say it has a negative gradient. For part C on the top, we can draw the line of best fit like that, right, with a positive gradient. The correlation can be moderate. In that case, not strong, moderate, right? This one too, my line of best fit can come somewhere around here. Okay, now drawing the line of best fit can be made easier if you have at least two points given, right? If you find the mean of each variable, then use to create a ordered pair. So that would be the mean of all the x values, that would be mean of all the y values, and then plot the point. After you plot the point, this point will be one point that your line of best fit should cross. So the dot that you will be drawing with this coordinate, it has to stand out from the rest, and your line of best fit should cross that mean values that you will be finding. Okay, we are going to look at an example, right? This is our set of values that we will be. So ages and percentage of population, right? Part A says represent that using the scatter diagram. You already know all the blue dots are plotted from the table here. Those are all those points that's shown here, right? It says draw the line of best fit, number 1, and then find its equation. Write the equation in the gradient form. Okay, right. So to find the gradient, so once we want to draw the line of best fit, we have to find the mean of all the ages separately, and then all the percentage of population. So to find the mean, I'll add all the scores and divide by 9. I have 36.4. To find the mean of y, I will again add all that, divide by 9. So I have my means at 36.4 and 50.8. You can see that. Can you see? But red one is my mean, right? So when I'm drawing the line of best fit, it's important that you draw your means in a different color, and the line that you will draw as your line of best fit should cross your mean, right? So number 1, you will find the means and then plot it on the graph and then draw a line of best fit. Your line of best fit should cross the means. Next, part B says we had to find the equation of my line of best fit. Okay, once again, you know how to find the equation of a line. You will use the formula y minus y1 is equals to m into x minus x1. First thing, you will need the gradient. So you can take any 2 points. The student here has taken in the example, the first set of coordinate was 0, 0. The second set of coordinate was this, 50 and 70. So using these two, we find the gradient 7 over 5. And once you will use it in the formula, y minus y1 is equals to m into x minus x1. Your value of the gradient that you found out was 7 over 5 from the example. And coordinate of a point, we can say, let's take 50 and 70. That would be your x1, y1, right? Let's substitute in the formula. Y minus 70 is equals to 7 over 5 into x minus 50. You will expand the bracket. Y minus 70 is equals to 7 over 5x minus 350 over 5, right? This minus 70 will come as plus 70. Y is equals to 7 over 5x minus, and you can simplify that and write your answer there. So it will be in the form of 7 over 5x. Thank you.